Welcome. Today I'm going to discuss the installation of a geothermal heating and cooling system using a pump and inject well source. Good morning. Thanks for taking your time to watch this video. My name is Mike McVeigh. My company is Paramount Geothermal. And today we're going to talk about the installation of a geothermal air conditioning system in Florida using a pump and inject open loop well system. This system is a 4-ton system, and it is replacing an existing split system that had an outdoor unit with the compressor that was geothermally cooled from a horizontal slinky loop. And I'm replacing it now with a 4-ton integrated unit that's in a closet downstairs in the main floor of the house, and it is using an integrated unit that has the geothermal heat pump and the air handler included in it. So I hope you enjoy the video, and thanks again for your time. This is the pump and inject well field. You'll see in the far distance what is the pumping well. It is a 1 horsepower motor set at 40 feet with about 100 feet of 1 1/4 inch drop tube from that pump that sits into the deep aquifer, goes past the surface aquifer through the limestone and into the deeper aquifer here on the coast of Florida. In the foreground here is the injection well. So basically this system pumps water out of that distant well, runs through some piping through the ground over to the house, through the geothermal heat pipe equipment in the house, is returned down, back out of the house, through the ground, and back into this well that you're looking at right in front of you. This pump receiving well here, injection well, is set at a 40-foot drop tube of 2-inch diameter, and basically the system runs at a 40 psi pressure, and the injection well has about 12 psi pushing water back into the well, and that's all a function of the drops through the system and the setting. The pump is a variable frequency control or variable speed drive pump, and it will vary its speed to maintain the pressure at 40 psi, and the heat pump will adjust how much water it wants to draw out of that system based on how much heating or cooling, in this case, it needs to provide. This is another angle view of the pump well. You can see a large sediment filter that I've put in there to try to capture any debris that comes through the ground. Interesting feature, this is a clear-walled sediment filter. Here in Florida there's enough organic material in there that when exposed to sunlight, it will actually, the little organic creatures turn black to block the sunlight, and it will quickly coat that clear casing. So we'll wrap that sediment filter with aluminum foil to keep the sunlight out. Now, some of these little pipes around the front are really to keep the gardener from smashing into it. Many people will put an artificial landscape rock, hollow landscape rock, to cover this so that it's more pleasing in the landscape. This is the geothermal variable speed Grundfos pump control to CU301. And it basically is a very simple unit. It's very nice. Basically, you see a few arrows on there. You can set it to whatever pressure you like. These are often used in homes with just conventional water wells for their homes. And you can dial that to 60 psi, and your faucets will always have 60 psi, which is a nice feature. But for this geothermal system, it also works very nicely because it only runs the pump with enough power to provide the amount of cooling that's needed into the heat exchanger. So it reduces energy quite significantly. In this closet we have a Climate Master TZ22 4-ton unit. We replaced the air handler that used to sit in here. Put this unit in. You can see the rubber hoses that come into the unit. They go down to the garage and then out through the ceiling of the drop ceiling in the basement, out through the walls and out to the pumps. We have not yet hooked up the desuperheater lines, which we will shortly. But those will provide all of the hot water that is needed, and basically they just use the high temperature water off the early coils of the heat exchanger to pump very hot water into the hot water tank, so you're using the geothermal energy for heat. This unit is very efficient. I measured it at about a little over 26, and I'm very pleased with that. This is a digital controller, and it's a diagnostic tool. And it shows all of the basic information that you need to operate this system. When it's on, and when the display will read it, it shows it doesn't show in the video, but basically this will show you the entering water temperature when this unit is running now. Water's coming in at about 76.6, I'm sorry. About 77 degrees is the constant water temperature pretty much throughout Florida. And the water's leaving at 86. The heat pump regulates that to keep about 10 degrees difference between the water coming into the unit and the water going out. This unit is providing air coming out at 51 degrees, and it's currently running at second stage. It's a two-stage compressor and a variable speed blower motor, which currently is running full power, 1500 CFM. Not quite. It's a 1500 CFM, about 1145 RPM, pretty close to full power, and it's chilling the house down very nicely. So all of the information in this unit can be accessed through this control. And here we have Jay Egg of Egg Geothermal, noted author of a number of HVAC textbooks with McGraw-Hill, who very generously stopped by to take a look and give me some advice, and I promptly put him to work. He's working on the thermostat installation right now. Jay and I have worked on a number of geothermal projects, and he's been in the business well over 30 years and was involved in the initial installation of this project in 1990.
Wow, that's a long time.
Here we have the thermostat for this system. I selected a Honeywell unit for this. It's a Wi-Fi unit, and currently set to 70 degrees. It was a little warmer in the night, so the customer just dialed it down to cool it off a little bit, and it's running just great. Thanks for watching the video. Geothermal heating and air conditioning is the most efficient, cleanest, and comfortable way to heat or cool buildings from homes to large industrial facilities. Geothermal uses the free heat from the earth to provide the most elegant way to condition the air. Geothermal systems use less than half the energy of conventional systems and will last 3 times longer. Geothermal is the premium answer for fine homes and large buildings, since it not only is comfortable, but it has no outdoor noisy units. For industrial buildings, geothermal is cheaper to install than conventional systems using cooling towers. It is a renewable energy source. Residential facilities are eligible for a 30% tax credit, and businesses are eligible for a 10% tax credit, plus an accelerated 5-year depreciation. Geothermal energy for heating and cooling. Elegant, clean, efficient, comfortable, and affordable. Thanks again for watching this video, and I hope you enjoyed it. Feel free to contact us at ParamountGeothermal@gmail.com if you have any questions.